All right, so we looked at some parent function shapes the other day. And what we notice here when we look at these things, if we, let's just take these examples right here, how about? These are representative of what all the graphs are going to look like if I take even powers of x and odd powers of x, right? The even powers of x all look basically like a parabola. The bigger the exponent gets, so x to the fourth you can see is a little bit more squared off. If I were to go into Desmos, and I'll just kind of show you, demonstrate what I mean here in Desmos. Okay, if I look at even powers of x, like if I do y equals x squared, there's my classic parabola, right? Okay, if I do y equals x to the sixth, look what it's done. It looks the same, only the sides get steeper and it gets more squared off. What do you think it's going to look like if I do y equals x to the 100th? What do you think that graph's going to look like?
The bottom line will get longer.
Say it again.
Like the bottom line will get longer.
Will get a little bit longer. It's going to be it's still going to go through the point 1, 1, for example, though, isn't it? Right? Like if let me put I'll show you something. If I put a point on here, if I put the point 1, 1 and the point -1, 1, all of these curves are going to go through those points. It's just how square is the base going to be, right? So if I pick x to the 100th, it looks pretty square, right? It's not square. If I zoom in, you'll see that it really is curved, but it's just much more square. Okay, everybody get the idea? Okay, what kind of symmetry do all of those graphs have, though? How would you describe the symmetry? They all basically look like that, right? Like a parabola. How would you describe that symmetry?
The line symmetry is the
X equals 0 would be the line of symmetry, right? Just like it is for our parabola. And that would be, if I wanted to demonstrate that symmetry, if this were graph paper, I could put a crease in the paper and just fold it along that vertical line and they'd overlap, right? We've all seen that before, okay? Okay, so there's the symmetry part. Now, what about the end behavior? For all these functions, if I'm an ant walking on the function, if I want to go really far to the right, so I want to look at the right end behavior of the function, the way we'd say that in math is x is going to approach positive infinity. When we say as x approaches positive infinity, what we're really asking is, okay, well, if the x coordinate of the ant's position, approached positive infinity, what would the y coordinate be doing? What would it approach? Say it again? Well, okay, now look, if you're onto something here. If I'm going to the right forever, what's y doing? It's going up forever, isn't it? So the right, it's positive infinity. There you go. Good, so the right end behavior is up, meaning as we go infinitely far to the right, the function is going to continue to go up forever. What's the left end behavior for an even power of x? As x approaches negative infinity, what am I doing? Going up, right? Y is also, or f of x is approaching positive infinity. So we get positive end behavior both to the right and the left for an even power of x, okay? Now let's look at the odd powers. So if I take, instead, if I do x cubed, well, there's my x cubed graph. Now it goes through the point 1, 1 and the point -1, -1, right? Well, what about x to the 7th? It's going to do the same kind of thing, only it's just more squared off, right? The base gets more squared off. So what is y equals x to the 101th? What's that going to be? It's a really big odd power of x. What's it going to look like? Draw a picture with your hands. What's that going to look like? I mean, it's going to be, what do you think? Really squared off, right? But it's going to look basically like the red graph, only much, much more squared off. There you go, right? Again, it's not square. If I zoom in, I can see it's actually curved, but it just looks pretty squared off, okay? So for an odd function then, first of all, what kind of symmetry do we have? I think maybe, I don't know if we said any of this. I can't remember where we left off last time. So an odd power of x, what kind of symmetry? It's not folding symmetry. What is it? Good, it's rotational symmetry about the origin. If this is graph paper and I put a tack in the origin, I could spin that thing 180 degrees and it would overlap perfectly, right? Okay, we're not really as concerned about the symmetry for now. We'll get back to that topic later, but we are the end behavior. What's the right end behavior for an odd power of x? Right end behavior is what? How would you describe that? Up or down? Up. Yeah, right end behavior is up. So as x approaches positive infinity, f of x or y approaches positive infinity, right? Left end behavior. Left end behavior is down, right? So as x approaches negative infinity, y or f of x also approaches negative infinity. Okay, give me 1 to 5. Is that making sense what we're doing? Okay, so we can come up with some really simple, one other thing we want to experiment with. And this is just a review. We've talked about this already. What if I graphed y equals negative 2x cubed? What's that going to look like? If I multiply an x cubed function by a negative number, what's that going to do to the function? What's that going to do? The 2 is going to stretch it a little bit, right? But I'm more concerned about the negative. What's the negative going to do? What do you think? Gavin, you got an idea? Okay, yeah, it's going to flip it, isn't it? Yeah. So if I look what happens here. If I do y equals negative 2x cubed, yeah, it's going to flip it around, right? So it reverses the end behavior. Same thing is true if I did something like if I wanted to graph, there's my x squared. What if I graph negative 2x squared? Well, what's that going to do? If I turn that on, it's just going to, again, it's just going to reverse the end behavior. So we come up with a really simple recipe for determining what the end behavior of a polynomial is going to be. Okay, very simple. If the leading coefficient is positive and it's an even degree, then doesn't that make the shape of the end behavior like that? It's going to be up to the right and up to the left. Okay, what happens if I have an even degree with a negative leading coefficient? Well, we just saw that that's going to make the end behavior reverse. So now it's going to be down to the left and the right. For an odd degree polynomial, right, where the biggest power of x is odd, if the leading coefficient is positive, we saw a little bit ago that that's going to look like x cubed. Positive end behavior on the right, negative end behavior on the left. If I multiply an odd degree polynomial by a negative leading coefficient, it's going to flip it around. Flip the end behavior around. Okay, now the important thing here is that we don't really care what's going on in the middle. All we care about is the end behavior, right? So I could take something really complicated in Desmos, and you guys make a prediction for me what the end behavior is going to be for that function right there, y equals 0.3 x to the fifth minus 2x cubed plus x squared minus 3. What's the end behavior going to be for that function? For this guy. What do you think? Hayden, what do you suppose the end behavior is going to be? Okay. Anybody got an idea? Okay, let's use our recipe. What's the degree of the polynomial? 5, right? Degree is 5, okay? Is the leading coefficient positive or negative? What is the leading coefficient? 0.3, right? That just means the coefficient of the leading term, biggest power of x. So that means I've got a positive leading coefficient and an odd degree polynomial. So that's going to look like x to the fifth. The end behavior is going to be just like that function. The function is going to be a little bit more complicated, right? If I turn this one on, it looks a lot more complicated. But if I zoom out a whole bunch, they start to look pretty similar, don't they? See my point? Okay, so we're not really going to concern ourselves with all the stuff that's going on in here. I just know that the leading term, I can just ignore everything except the leading term. The leading term has a power of 5, so it's an odd degree, positive leading coefficient. Man, I know that this thing is going to be up to the right and down to the left. And it's going to do crazy stuff in between the ends. But I'm not worried about that for now when I'm talking about end behavior. Okay? Everybody get the idea? Let's try another one. I'm going to make up another weird one here. So let's do y equals, let's make this negative 1 divided by pi x to the 11th plus 1,000 x to the 10th minus 5. Okay, talk about that with your neighbor for a second. I want to know what's the end behavior going to do on that guy. Okay, so what's my right end behavior going to be? Hayden, I'm coming back to you, buddy. My right end behavior. It's going to be down to the right. Good. And to the left? It's going to be up to the left. Good. And we know that because it's a negative leading coefficient and an odd power of x. And I might have to zoom out a ways to see that because I got a really big coefficient of x to the 10th. But guaranteed, if I zoom out far enough, let me do this. I'm going to kind of tweak this a little bit. So I'm going to make my x go from negative 0.1 to positive 0.1. And now I'm going to zoom out some more. Okay, it looks like it's going up. Oh, I did the wrong thing there. Whoops, went the wrong way. No, I didn't. Got to go out a whole bunch. Man, I got to keep going out. I probably shouldn't have made such a big coefficient, but I want to prove a point here. Make that red. Okay, let's do this again. We're going to go. Okay, there. Finally, it's starting to do something. Okay, let's go. And I picked kind of an unfortunate one. Here, let me make this coefficient a little bit smaller. That was too ridiculous. How about if I do something like that? Or even something like that. There. Now you can see the end behavior like we expected. And make that 5. So we can see it a little bit better. Oh my goodness, I picked a bad one. Picked a really bad one. There. Now you can see it. Whew. Wow, that was a lot of work for very little payoff. But you get the idea? Okay. Okay, so let's try this a little bit then. I want you to determine for these graphs here then, for number 7 and number 8, I want to know, it's a complicated polynomial, but we don't care about that. I just want to know what's the sign of the leading coefficient, and is it an odd or even degree polynomial? Ooh, that's pretty big. So what do you think for number 7? What's the sign going to be? Negative leading coefficient, right? Even or odd? It's going to be even, isn't it? How come? Because the end behavior is going the same way, right? If we go back and look at our recipe, for even degree functions, that's when the end behavior is the same to the left and right. This just happens to be negative leading coefficient even. Okay? How about number 8? Positive leading coefficient and odd. There you go. Okay. Okay, end behavior. How about this one? Now we're going to look at just a little, we're going to use more of calculus notation here. So let's think what this means. Let's interpret this statement. So we've got this function f of x up here. F of x equals negative x squared plus x. So how would we characterize that then? How are we going to know the end behavior? Describe that function so we can predict end behavior. Make sense? Negative leading coefficient, even degree, okay? So what's that mean? What's the behavior going to be then? End behavior? If it's even degree, negative leading coefficient? Yeah, I'm doing that, aren't I? Right? Okay, so we know it's looking like that. So as x approaches infinity, how do we interpret that? That means as we're going to the right forever, okay? Okay, so we're going to the right forever. What is f of x approaching? F of x is just y. Well, based on our picture, what's it approaching? Negative infinity, yeah. right? So it's going to do something like that, isn't it? It's going to go down because f of x, y is the vertical variable, right? So as y approaches negative infinity, vertically speaking, we're going to negative infinity, which is down forever, right? So f of x approaches negative infinity. How do we interpret that part? That just means we're going, whoops. That just means we're going down forever, right? Right forever, down forever. As x approaches negative infinity, how do I interpret that? X is my horizontal coordinate. So what's that mean? How do I interpret that? Left forever, right? Going infinitely far to the left. F of x is doing, well, we already drew the picture. It's going down, right? So we know, again, we're getting that kind of behavior. F of x is approaching negative infinity, okay, which means down forever, okay? How about this one? Make a prediction. As x approaches infinity for this function, what's f of x going to approach? So we're looking at end behavior. And as x approaches negative infinity, what's f of x going to approach? Take a second. You can talk with your neighbor. What do you think? So Gavin, what's my right end behavior going to be for that function? Down. Good. My left end behavior? Up. So we're doing that. Okay, so it's going to look like that, right? So then what am I going to get here for, Allie, what am I going to get for my, what's the value, what is f of x approaching? As x approaches infinity, f of x is approaching, as x approaches infinity, so how do I interpret that? I'm going which direction forever? To the right on that function. F of x, that's my vertical coordinate. I'm doing what? Going down. There you go. Didn't you say up the first time? Think so. So I'm approaching negative infinity because of that, right? Okay, how about, let's see, if we go as x approaches negative infinity, what's f of x approaching? What's it going to be? Positive infinity, yeah. Because that means as I go left, I'm going up. Okay, we getting this? It's making sense? Okay, let's just try one more real quick. How about this one? As x approaches infinity, f of x approaches, everybody, what's it going to be for this one? Positive infinity, right? Because I've got a positive leading coefficient, odd power, so I'm doing this, right? I know my end behavior is going to look like an x cubed function. Like that, right? So that's positive infinity. As x approaches negative infinity, f of x approaches, Cray, what am I going to get? Negative infinity. There you go. Okay. All right, what about this one? Use the leading coefficient test to determine the end behavior. I guess I have the answer up there. That's kind of bad. Makes sense though, right? All I care about here is the leading term. That's it, right? I've got a positive, odd leading term. So it's going to do, oh, that's wrong anyway, isn't it? Positive, odd tells us which one. A, B, C, or D, which one's right? Looks like positive, odd is that one, right? Falls to the left and rises to the right. Does that make sense? Okay. Why do I have this thing on there? I don't even know what that's for. What is that? Oh, I don't know. Okay, how about that one? Be careful with this one. A, B, C, D, or E. A is 1, B is 2. You can vote with your hands here in a second.
Yeah, I'm not ready.
Okay. Did I do on that last one? Oh, never mind. Okay. So vote. What do you think? A, B, 1, 2, 3, 4, or 5. What's it going to be? Okay, oh man, I'm seeing lots of ones. That's good. It's got to be 1 because it's an odd degree, negative leading coefficient, so it's going to flip around and do that, isn't it? It's going to go rise to the left, fall to the right. Yep. So that guy. Whoops. Okay, what about that one? Yikes. That's a little tricky. We want to take a stab at that one? Is it B? It is. How come? Monica, I think you got it. How come?
There's no sign outside the parentheses. I don't know. That's what I went off on. There's no sign outside of the parentheses.
Okay, so there's nothing to distribute. Okay. A little more to it. Can anybody explain that? What do you think?
Is it because that power is even and like a negative to an even power is always positive?
Not exactly. Now, is that written? Let me ask you this: is that written as a polynomial? It's not, is it? Right? What would I have to do to turn that into a polynomial? What would I have to do? I'd have to expand it all out, wouldn't I? And this would be a Pascal's triangle one, right? Does anybody remember for row 4, remember what the coefficients are? Say it again. 1, 4, 6, 4, 1, yeah. So, and we could make that one, right? The coefficient should be 1, 4, 6, 4, 1. Good job. So we're going to get 1, 4, 6, 4, 1. Now the good news is you didn't really have to remember that, and you'll see why. If I were going to expand that out, then I'm going to get 1 times, what's my A? I guess we need to know that too. X. Good. So A is X. What's my B? Well, -4, right? So the first one is going to be 1 times A to the 4th. So I'm going to get 1 times X to the 4th plus 4 times A cubed. So X to the 4th times -4 to the 1, and so on and so forth, all the way down the line. That's a lot of work, but do I even care about any of those terms? I don't. All I care about is the leading term, right? Couldn't we anticipate without really even having to go through this whole exercise? I know that if I expand this thing out, the leading coefficient is going to be 1, right? By my Pascal's triangle stuff. And I know that all of the weight is going to be on the x's. So without even really having to think about this too much, I know that this is what I'm going to get for my first term. So it's going to be an even leading coefficient, or excuse me, a positive leading coefficient and an even power of x. So it's going to have this behavior, guaranteed, right? The other way maybe you could think about that is if we wrote it this way. I just want to do this once, just so you make sure everybody is thinking about this in a convenient way. There's x minus 4 to the 4th, right? if I were going to expand this whole thing out, well, when I do my distribution for the first two, the very first thing I distribute is x times x. That's going to be the biggest power of x is going to be an x squared, right? So I'm going to get x squared plus a bunch of other garbage. When I distribute that to the next one, I'm going to get an x cubed plus a mess, right? When I distribute that x cubed to this guy, I'm going to get an x to the fourth plus an even bigger mess, right? But again, I'm just getting a plain old x to the fourth. So it's got to be that guy right there. Give me 1 to 5 on that. Does that make sense? Okay. We don't care what the whole thing is. All we care about is what that first term is going to be, and it's going to be x to the fourth. Okay, same kind of thinking on that one. Think about that for just a second real quick. Oh, what happened? What's the verdict? What's the leading term going to be in this one? What do you think? When I distribute this whole thing out, what's first term going to be guaranteed? Okay, and you could probably tell me what it's going to be. What is it? X to the fourth, right? This is going to equal, guaranteed, it's going to equal x to the fourth plus a mess, right? But all we care about is the x to the fourth. When I distribute that whole thing out, this is going to give me an x squared. When I square that thing out, I'm going to get x squared plus some stuff. And when I distribute the biggest power of x to the biggest power of x, I'm going to get x to the fourth, guaranteed. Give me 1 to 5. Is everybody seeing that? Okay. So if it's x to the fourth, then we know it's going to rise to the left and the right. So it's going to be this guy. Right? How about that one? What are we going to get? What's first term going to be? What do you think? Yeah. How'd you get that? 7 times 2 is 14, and 3 times 3 is 9. Yeah. That makes sense? So I'm going to get, when I distribute the 2, I'm going to get x. Well, I can't distribute the 2. When I expand that whole thing out, I'm not just distributing the 2, but I'm going to get, when I square this out, I'm going to get an x to the 14th plus a bunch of stuff times, when I expand that out, my first term is going to be x to the 9th plus a bunch of stuff. So now when I multiply those together, I'm getting x to the 14 plus 9. X to the 23rd plus a big mess, right? So the leading term is just x to the 23rd, and the degree is 23. Okay? All right, that's probably a good place. I'm going to stop there. I think that's a good place for today.